All right, let's jump right in. Today, we're going to be exploring some exoplanets.
Yeah,
Ones that scientists think could maybe even host life, you know?
right.
And all this amazing research, by the way,
Yeah.
is coming from Discover magazine. Get ready for a wild ride, everyone.
It really is amazing. Just a few decades ago, we could only imagine planets orbiting other stars, and now
I know.
we're finding them and
Yeah.
studying their atmospheres,
Right.
even finding clues about whether they could have life.
It really is mind-blowing.
Yeah.
These aren't just numbers on a page. We're talking about whole worlds out there,
You got it.
potentially with life as we speak.
Right.
But before we go too crazy,
Yeah.
we should probably start with the basics.
Sure.
Scientists talk about the habitable zone or the Goldilocks zone
Uh-huh.
when they're talking about life on other planets.
Mm-hmm.
What does that even mean?
Oh, right. Yeah. The habitable zone is basically the sweet spot around a star where conditions are perfect.
Okay.
Not too hot, not too cold, for liquid water to exist.
Gotcha.
And water, as we all know, is essential for life as we know it.
It's kind of like finding that perfect spot around a campfire, yeah.
Exactly.
Close enough to stay warm, but not so close you burn to a crisp. Okay, so let's dive into our first exoplanet,
All right.
Proxima Centauri b. This one's close.
Yes.
Like really close. The closest known exoplanet to us.
Uh-huh.
It orbits a red dwarf star,
Right.
a little over 4 light years away. What is a red dwarf, by the way?
So a red dwarf is a type of star
Okay.
that's much smaller and cooler than our sun.
Right.
And they actually live a lot longer, too.
Fascinating. So Proxima Centauri b, is it all it's cracked up to be?
Well, it's a super Earth,
Okay.
which means it's bigger than our Earth,
Yeah.
but smaller than the gas giants we have in our solar system.
Oh, like Jupiter.
Right, exactly. And it might even have a rocky surface suitable for liquid water.
There's like
In fact,
what?
there is a big one. The radiation from its star is intense,
Are you like the...
very intense.
Huh. So even though it's in the habitable zone, this
Mhm.
radiation could be a problem for life.
It's a major problem. It could completely strip away the planet's atmosphere, which would make it really hard
Yeah.
for life as we know it to survive.
Wow. It's this constant back and forth, right? This
Yeah.
potential for life,
Yeah.
but then these super harsh environments.
Yeah.
It really does seem like finding a truly habitable planet is like,
Right.
I don't know, winning the lottery,
Is.
a cosmic lottery. Speaking of winning, let's move on to the TRAPPIST-1 system.
Okay. Yeah.
This one's got everyone excited.
It's for good reason.
Why? Because it's got seven,
Seven.
count them, 7 Earth-sized planets orbiting a single star. Can you imagine?
That's incredible.
3 of these planets, TRAPPIST-1e,
Yeah.
F, and G.
Are actually in the habitable zone.
Really?
Yeah. So picture it. Multiple planets in the same system, all potentially capable of supporting life.
That's like something straight out of Star Wars or something.
It's pretty wild.
But let's stick with TRAPPIST-1 for now. What makes this one stand out?
Well, based on its size and density, we think it's probably rocky and could have liquid water. Some scientists even believe it could have more water than all of Earth's oceans combined.
Seriously. That's nuts. All right, this one's definitely going on my planets to watch list.
Absolutely.
Okay, let's switch gears a bit. Let's talk about Kepler 186f.
All right.
This was pretty special, right?
It is. Kepler 186 was the first confirmed Earth-sized planet
Right.
that we found in the habitable zone of a star that's not our sun.
That's a big deal. So what do we know about Kepler 186f? Any chance of life there?
Kepler 186 is about 500 light years away,
Okay,
and it orbits a red dwarf star, just like Proxima Centauri b.
I see.
It gets about 1/3 of the sunlight that Earth does.
Oh, wow.
So it's probably a lot cooler.
So maybe pack a sweater if we ever get to visit. But seriously, how do scientists even study the atmosphere of a planet that's so far away?
It's a tough job, but they use a technique called transit spectroscopy.
Transit spectroscopy.
Yeah. Imagine a distant star.
Okay.
A planet passes in front of it, from our perspective.
Right.
When that happens, some of the starlight actually filters through the planet's atmosphere.
Interesting.
So by analyzing the changes in that starlight, we can learn about what the atmosphere is made of and even look for signs of molecules that might indicate life.
That's amazing. So it's like using starlight as a giant magnifying glass
Exactly.
to study these distant worlds.
That's a great way to put it.
Okay, speaking of atmospheres, our next exoplanet, LHS 1140b.
Yeah,
This one has a super thick atmosphere, right?
that's right. It does.
Why is that so important?
A thick atmosphere can really help a planet be habitable.
Oh, how so?
It traps heat, stabilizes the temperature, and even protects the surface from radiation.
So, like a giant shield.
Exactly.
Okay, and LHS 1140b,
Uh-huh.
it orbits a pretty chill red dwarf star, right?
Right. It's much calmer than most red dwarfs, which are known for being kind of, well, yeah, rowdy. They release powerful flares that could be really bad for life.
That makes sense. It's not just about being in the habitable zone. It's also about
Right.
whether your star is going to
Yeah,
blast you with radiation every other week.
exactly.
Okay, let's move on to a planet that's really making waves. K218b. This one sounds extra special because scientists have actually detected
Water vapor.
in its atmosphere.
Yep, you got it.
That's huge.
Absolutely. K218b is another super-Earth,
Okay,
and it's about 124 light-years away.
I see.
Finding both water vapor and evidence of carbon-bearing molecules,
Yeah.
the building blocks of life, is a major breakthrough.
So is this planet covered in oceans, or is it more like cloudy and humid?
That's what we're trying to figure out. It's much bigger than Earth
Okay.
and likely has a really thick, hydrogen-rich atmosphere.
Yeah.
But some recent studies suggest there could be a whole ocean under those clouds.
That's insane. We might be seeing an alien ocean from hundreds of light years away.
I know, it's pretty amazing.
For our last stop on this leg of our exoplanet tour,
Okay.
let's head to Gliese 12b. This one seems like a bit of a mystery.
It is intriguing. It's roughly the size of Venus, but it orbits its star, which is a cool red dwarf, much closer than Venus orbits our sun.
Wow, that's got to be hot.
You'd think so, right? But what makes Gliese 12b so interesting is that despite being so close,
Yeah.
its orbit might actually allow for temperatures that could support life.
So it's like an exo-Venus?
Yeah,
But with a twist.
exactly.
It's crazy how a planet's orbit can make such a difference.
It really does. And studying Gliese 12b's atmosphere could help us figure out how planets that are so close to their stars
Yeah.
can hold on to their atmospheres at all, which is super important for anything to be habitable.
That's a great point. So we're not just learning about this one planet. We're
Yeah.
learning about a whole category of planets.
Exactly. Each one we study teaches us more about the universe and the incredible variety of planets out there.
That's pretty amazing. Wow, we've covered some serious ground here.
We have.
6 incredible exoplanets,
Wow.
each with their own story, their own potential for life.
Yeah.
But it feels like we've barely scratched the surface.
Right.
What's really exciting is that scientists aren't just, looking at these planets.
Uh-huh.
They're actively trying to learn more
Absolutely.
about what's going on out there.
They're developing new technologies, new research methods all the time. It's a really exciting time to be studying exoplanets.
Okay, so let's go back to some of these exoplanets and really dive deep
Okay.
into the challenges and opportunities they present.
Sounds good.
Let's start with Proxima Centauri b.
Mm-hmm.
We talked about that intense radiation from its star
Yeah.
as a big hurdle for life.
Yeah.
What are scientists doing to learn more about that?
Well, they're using really sophisticated computer models
Okay.
to simulate the planet's atmosphere
Right.
and how it interacts with all that radiation.
I see.
They're basically trying to see if Proxima Centauri b can even hold onto an atmosphere at all,
Wow.
and if it can, what it might be made of.
It's like a cosmic puzzle,
It really is.
trying to piece together these clues from billions of miles away. Speaking of puzzles,
Yeah,
what about the TRAPPIST-1 system? With 3 planets in the habitable zone,
right.
how do you even choose where to start looking for life?
That's a great question.
Yeah.
It's a big challenge, actually, prioritizing which planets to study first. We have limited resources,
Sure.
limited telescope time,
Right.
so scientists have to be strategic. In the case of TRAPPIST-1, the James Webb Space Telescope is going to be a real game changer.
How so?
Well, it's incredibly sensitive,
Yeah.
and it can analyze the compositions of planetary atmospheres.
Right.
So it's really going to revolutionize our understanding of these planets.
It's amazing that one telescope could unlock so many secrets
Oh, yeah, right.
about these distant worlds. So, for example, with TRAPPIST-1e,
Uh-huh.
what could the James Webb Telescope tell us?
Well, it could analyze the light passing through its atmosphere, and it could reveal the presence of gases like oxygen, methane, or even more complex organic molecules.
Wow.
You know, the kind of things that could point to biological activity.
So it's not just about finding water.
No.
It's about finding the chemical signs of life.
Exactly, those fingerprints of life.
Let's talk about Kepler-186. I'm curious how scientists can even tell if a planet so far away has an atmosphere,
Right.
let alone what it's made of.
Well, that's where transit spectroscopy comes in, like we talked about before. Remember, when a planet passes in front of its star, some of the starlight shines through the planet's atmosphere.
Okay.
And different gases in the atmosphere absorb different wavelengths of light.
So it's like a fingerprint.
Exactly. Each gas has its own unique fingerprint.
That's amazing.
And by studying these fingerprints, we can figure out what the atmosphere is made of.
Wow.
And whether it might be suitable for life.
Like finding oxygen and nitrogen, things like that.
Exactly. The right ingredients for life as we know it.
Let's move on to LHS 1140b, that super-Earth with a thick, protective atmosphere. What are scientists trying to learn about this one?
One of the big questions is about volcanic activity.
Volcanoes.
Yep. Volcanoes can release gases into the atmosphere, which can change a planet's climate.
Oh, I see.
They can make it warmer or cooler depending on the gases they release.
So it's a balancing act.
It is.
Too much of one gas could make the planet uninhabitable.
Exactly.
But how do they study volcanoes on a planet that's so far away?
Well, they look for changes in the planet's brightness,
Okay.
which could indicate an eruption.
Interesting.
And they also analyze the light passing through the atmosphere, looking for those volcanic gases.
It's amazing how they can get all this information.
I know, it's incredible.
From these tiny little signals. What about K218b? The one with the water vapor and carbon molecule.
Yes, that one's a top priority for future observations.
What are the next steps for studying it?
Well, we need to confirm if there really is a liquid water ocean under those clouds, and we need to learn more about those carbon molecules.
What kind of missions would it take to do that?
We'll need even more powerful telescopes. Future space telescopes, like the Ariel mission from the European Space Agency,
Oh, yeah.
are going to be specifically designed to study the atmospheres of exoplanets. They can analyze a much wider range of light,
Okay.
which means they can detect a lot more molecules.
That sounds promising. Finally, let's talk about Gliese 12b, the exovenus. What are scientists most interested in learning about it?
They really want to understand how its atmosphere interacts with the stellar wind.
Stellar wind.
It's a constant stream of charged particles coming from the star.
Oh, right.
It can actually strip away a planet's atmosphere over time.
So it's like a tug of war.
Exactly. The planet's gravity is trying to hold onto the atmosphere, and the stellar wind is trying to blow it away.
Wow.
And figuring out how planets like Gliese 12b manage to hold on could help us understand what makes a planet habitable, especially around red dwarf stars, which are super common.
So, again, we're not just learning about one planet.
All right.
We're learning about a whole class of planets.
Exactly. Each one is a piece of the puzzle.
That's really cool.
Yeah.
Man, it's incredible to think about the scale of all this.
I know, right?
Planets and stars and like whole systems out there.
Mm-hmm.
And we're just this tiny little speck
Yeah.
trying to find other life. It's crazy.
It really is.
And the fact that we can even have this conversation, that we can actually find these planets orbiting other stars, that's amazing in itself.
It really speaks to how far we've come as a species, you know, in terms of our technology and our understanding of the universe.
It wasn't that long ago that this was all science fiction.
Right, exactly.
And now it feels like we're on the verge of discovering so much more.
We are. And with each new exoplanet we find, each new piece of data, we get closer to answering that big question.
The big one. Are we alone?
Exactly.
Yeah.
And, you know, it's not just about finding another Earth.
Right.
It's about understanding life itself.
What do you mean?
Well, what other forms could life take? What kind of crazy environments could it survive in? These are questions that really challenge our understanding of what life is and what it could be.
That's what I love about this topic. It's not just about science. It's about expanding our view of the universe.
Absolutely.
And exploring all these amazing possibilities.
It really is about pushing the boundaries of our knowledge.
So let's talk about that. Let's say there is life out there on these distant planets.
Okay.
What would it even look like?
That's the million-dollar question, right?
Yeah. I mean, with all the different kinds of exoplanets we've talked about, it's hard to imagine alien life looking anything like us.
I know. It could be totally different. It could be based on different chemistry, adapted to extreme environments, or even exist in forms we can't even imagine.
It's like opening the door to a whole new reality.
It is.
Where all the rules we know about life just go out the window.
Exactly. I mean, imagine creatures that breathe methane, or plants that glow in the dark, or maybe intelligent beings that communicate through telepathy.
That's wild.
The possibilities are endless. And as we keep studying these exoplanets, we're opening ourselves up to the chance of discovering life that's totally unlike anything we've ever seen.
This deep dive has been a wild ride.
It has.
It's clear that the search for life beyond Earth is just getting started. Any final thoughts for our listeners out there?
Well, I would just say this. The universe is vast and full of wonders. Every star you see at night could have planets.
Wow.
And some of those planets might have life. So keep looking up, keep wondering, and never stop asking questions. The adventure is just beginning.
I love that. That's a perfect way to end this deep dive.
Yeah.
Thanks for joining us on this incredible journey.
My pleasure.
As we explore these exoplanets and the search for life beyond Earth, keep those spacefaring minds engaged. And remember, the adventure is just beginning.